arc length, area of a sector, and area of a segment. Let's define these and take a look at some example problems. So the first one we're going to take a look at is going to be arc length. An arc length in a circle, the length of the arc is the portion of the circumference that is intercepted by the angle. So for example, if this was my angle AOB, then arc AB is going to be my intercepted arc. If I wanted to find the length of that, then that's going to be an actual measurement or the portion of the circumference that is going to be intercepted here. The formula that we can use to find arc length is going to be arc length is equal to our central angle divided by 360 degrees times our circumference. So a couple important things here. First of all, we want to make sure we're understanding the difference between an arc length and an arc measure. Arc measure is going to be something that's given in degrees. For example, in the picture that we have here, our arc measure is equal to our central angle. So those are given in degrees. An arc length, this blue section here of this intercepted arc, is going to be something that's going to be like a measure that's going to be measured in inches or feet or that type of units. It's not going to be a degree measurement. Now, a couple side notes about our formula for finding this. The first side note is to remember our formula for circumference. And circumference is equal to 2 pi r. That's the formula that we use to calculate our circumference. So that's what we're substituting in for that circumference value. And the other note that we need to be thinking about here, which we're going to talk about this in a second, is going to be that if you are using degrees as your units, then you use 360 in your formula here. However, if you are instead using radian measures, which we're going to talk about in about a second here, your formula is going to change just a little bit to be your central angle divided by 2 pi times your circumference. So let's take a look and see what radian measurements are. In radian measures, theta is equal to the arc divided by the radius. So if I was to show this in a circle, I would have my circle, I would have my center point, could draw my angle in, and theta is going to be represented where we put that angle. Here, my radius, I can draw here. In my arc, I would represent with the yellow. So theta is equal to my arc divided by my radius. Now we know that we are going to be given a radian measure because it would say, for example, we have 5 radians. Or our theta was equal to 2 pi. Or theta is equal to 1/2 pi radians. The units are going to change here. So for this, we're dealing with radians. Now we can switch back and forth between degrees and radians. For example, if I was given, say, 90 degrees, and I wanted to turn that degrees into radians, I can do so by multiplying the degrees by pi over 180. So if I multiply that, I get 90 pi over 180, which is equal to, if I simplify those out, I get a 2 pi over 2. So that means that 90 degrees is equal to pi over 2 radians. If I wanted to take my radian measurement of pi over 2 and convert that back to degrees, all I would have to do is multiply that by 180 over pi. So from here, I can cancel out my pi's, and I'm left with 180 over 2, which is equal to 90 degrees. Next, we're going to take a look at the area of a sector. So when we have a sector of a circle, it's going to be the portion of the circle that is enclosed by 2 radii and an arc. So if I was to draw what this looked like, I would have a circle, and I need 2 radii. So I have my center point, 1 radius, there's my second radius. And so I'm going to say that the sector of the circle is the portion that is enclosed by my 2 radii and my arc. So this shaded blue section would be my area of my sector. So with this, when we see the word sector and we're thinking of the area of the sector, we want to be thinking pizza slice, because it looks like a slice of pizza. Now, there are lots of formulas we could use to figure out the area of the sector. If we wanted to find the full circle, then that would be pi r squared. If we were going to find if our sector here was a semicircle or just half of the circle, then we're taking half of our full area. If we wanted to find a quarter of the circle or a quadrant there, then that's equal to 90 degrees. So we're taking our area and multiplying it by a fourth. But the formula we're really going to focus on here is going to be finding the area of any sector, meaning it doesn't matter which degree angle we have, we can find that area of the sector. And this first one that we have that uses 360, we're going to use this area formula if the problem is given to us in degrees. So if my problem is given to me in degrees, I'm saying, say n is equal to 45 degrees. Then what I would do is say a is equal to 45 over 360 times pi times my radius squared. And from there I can find my area. Now instead, if my theta value is given to me in radians, then I have to use this 2 pi r instead. The last term we're going to take a look at here today is going to be the area of a segment. So we just talked about a sector, and we talked about that blue shaded section here, and we had that slice of pizza to represent a sector. Well, if we're going to talk about a segment is just going to be the crust of our pizza slice. So with this one, for a segment, we want to think the pizza crust. If we were to put it in some more math terms here, we could say a segment of a circle is the region that is bound by a chord. There's our chord. And the arc that is subtended by the chord. So here is our arc. So it's that section right there. The segment is partially curved figure left when the triangular portion of the sector is removed. So if you wanted to find the value of that segment, then what you would do is you would take your sector, you would subtract out this yellow triangle here. Take your sector, subtract out that triangle, and we'd be left with that green segment. So to put that in a formula, I could state that the area of my segment is equal to the area of my sector minus the area of my triangle.